Hello everyone, my name is Atish and in this learning dialogue we'll see what is partial differential equation of first order and first degree. Okay, so as you know that in the last learning video we have done with the partial differential equation, then some of the notations that we have to stick with that notations, and we have seen how to form partial differential equation by eliminating arbitrary constant and arbitrary functions. Okay, and in this learning dialogue we'll see a very new topic in this unit, that is PD of first order first degree. So let us understand this. So it's like, let z is equal to f of xy, where we have already discussed in detail. Okay, x and y are independent variables, z depends on x and y both. Okay, if z is equal to f of xy, then what? Then the general form of first order and first degree equation is PP plus QQ. Let me write it in the new line. Is PP plus QQ is equal to R, where what is this P, Q and R? This P, Q and R are functions of x, y and z. Okay, this capital P, Q, R are the functions of x, y, z, and this is known to you. What is this P? This P stands for del z by del x. This Q stands for del z by del y. Okay, now this can also be written as like, that is P del z by del x plus Q del z by del y is equal to R. So same equation can also be written like this, and this equation PP plus QQ is equal to R, or the equation of the form P del z by del x plus Q del z by del y equal to R, this is known as what is it? This is known as Lagrange's equation, and that is the name of the very first topic that we are going to learn now onwards. Okay, so actually we have to see what is Lagrange's equation. Just we have seen. Now we'll see how to get the solution of Lagrange's equation. Okay, so let us see how to get the solution of this type of differential equation. So I am just going to write one sentence over here. And as you all know that we are following the working rule to get the solution. So let me write down here, solution of Lagrange's equation. Solution of Lagrange's equation. Do you remember what is this Lagrange's equation? Just that we have seen PP plus QQ is equal to R. Okay, now to get the solution of this Lagrange's equation PP plus QQ is equal to R, we need to follow some steps. So let me write it as working rule. So the working rule says, step number 1, write down the given equation. Write down the given equation in the form PP plus QQ is equal to R. Okay, that is your first step. Sometimes it will be given the form like this, sometimes it should not be given like this. Then you have to arrange and try to get this form. That is the very first step. Step number 2 says write down, say this is to be my equation number 1. Write down its auxiliary equation. Write down its auxiliary equation. Auxiliary equation. The another name of this auxiliary equation is subsidiary equation or subsidiary equation. So let us see what is the subsidiary equation. The auxiliary equation for this is dx by p, dy by q, and dz by r. Okay, so this is my equation number 2. Equation number 1, equation number 2. Now, my objective is to get the solution of the equation of the form pp plus qq is equal to r, right? Now, I can get the solution by solving this auxiliary equation 2. So, my step number 3 is solve this auxiliary equation 2. Okay, to obtain the integral solution, or you can say integral surfaces also. Solve equation 2 to obtain integral solution, sometimes also called as integral surfaces. Integral solution u function of x, y, z is equal to a and v x, y, z is equal to v function of x, y, z equal to b, where a and b are arbitrary constants. Okay, now once you get this equation number, when you solve this subsidiary equation, you will be getting two integral surfaces or integral solution. Once you get this, write down the general solution. So step number 4 says write down the general solution of equation 1 we get. So what we get when you get this u and v, you just need to write down the general solution. So that general solution is phi of uv equal to 0. Where what is this phi? Where phi is an arbitrary function. Okay, now sometimes this result can also be write like u is equal to f of v, or v is equal to f of u. Okay, so depending on the problem, sometimes we write this solution like this. So this is all about the solution of Lagrange's equation pp plus qq plus r. Pp plus qq is equal to r. Now the all emphasis, you can write down equation 1, equation 2. Now your question would be, to solve this equation 2, I will be getting the integral solution. Then there must be a question striking on your mind that how to get the solution of this. Okay, so to get the solution of this, we have 3 different methods. Okay, and with the help of those 3 methods, we can easily get the integral solution of the given equation. Okay, so let me take now those 3 methods. Okay, so first of all, I would like to state down all these name of those 3 methods, and then we'll go by taking the one method and 2 example, then the second method and 2 example based on it, and like this. Okay, so next is method of solving. Method of solving auxiliary equation. And what is that auxiliary equation? Auxiliary equation dx by p dy by q and dz by r. So we have this auxiliary equation and we have to solve this to get the solution. But the question is how to solve. So to solve this equation we have different types of methods. So three different types of method we have. Method number one is named as method of grouping. Method of grouping. So what you need to do is, this is very simple method. You can like this method when you solve these examples. Okay. So method of grouping says you just club any two of the ratios. Like you can method of grouping like dx by p is equal to dy by q, or you can take dz by r is equal to dy by q, and something like whatever is suitable for getting the solution will make the group of those two ratios. Okay. So why I am taking two? Because I need two solutions. If there are four ratios, then I will be taking three. Okay, depending on the problem will be taking. So this is method of grouping. Now what this method of grouping says, you just club the two ratios, cancel out the terms if it is cancelled out. Okay, and just integrate to get the integral solution. That is the very simple method. When you solve the problem, you will find it very easy. Now the second method is depends on the method of grouping. So method number two says sometimes only one integral solution we will get by method 1. So in such case, what we are going to do, suppose we get one integral curve, one integral solution with the help of method 1, but we need two. Okay, so what we can do is we can make use of one solution to get the another solution. Okay, so we use solution 1. So we use solution 1 to get another integral solution. Okay, this is the second method, and third one is the very important, very easy if you know it, if you get that method. Otherwise you may find it difficult. Okay, so the method third is method of multipliers. Methods of multipliers. So this is the third method that we have. So what we are going to do in this method is we'll look for the set of non-zero multiplier. Okay, say element. So let me write it as like using a set of non-zero multipliers, say L, M, N. It may be anything. You can take ABC or LMN, depends on you. Element such that you can write dx by p. Yes, dx by p is equal to dy by q is equal to dz by r. That is, each ratio of this equation 1 can be written as L dx plus M dy plus N dz upon LP plus MQ plus NR. Something like that. Okay. Now we have to choose this element or select these non-zero multiply in such a way that this denominator should get 0. So if LP plus MQ plus NR equal to 0, then by principle of algebra, LDX plus MDY plus NDZ also equals to 0. Okay, and then what you have to do, you just have to integrate this to get the integral curve. That would be the first integral curve or integral solution. Okay, then repeat the same process to get the another integral curves. Okay, so these are the three methods that will be taking in getting the solution of this equation of the form dx by p dy by q is equal to dz by r. Okay, so thank you for this thank you for watching this learning video and enjoy learning. I would like you to go through these important things first, and then you will be enjoying the problem solving, okay, on this topic. So thank you, and in the next learning video we'll be discussing method number 1, that is method of grouping. Okay, thank you and enjoy learning mathematics. Thank you.